Are we having fun yet? Of course we are. It's math. So this one's a sweet one. It essentially has two things affecting it. And again, you could start with a table on here. I'm going to throw in gray. That's the original square root function. If the plus one wasn't here and the plus one wasn't here, it starts at the origin, goes up to 1, 1, goes up to 4, 2, goes up to 9, 3. Just square roots. Every point on there is just a basic square root. So I'm hoping, even if they're just doing 4 of these, you now can see how this is going to affect it. This is shifting the y-intercept up 1. And this is shifting the x value of the vertex to the left 1. Because now we can plug in 0, but we can plug in a negative number. What negative number could you plug in there? And of course you probably know -1. So that 0, 0 point is now over here at -1. And this is shifting it up to +1. If I plug in -1 here, I get 0. 0 plus 1 is 1. Hopefully that makes sense. So, we want to get you to get to a point where you can see how these shifts are taking place without having to make an entire table of values. So I took that, origin point, moved it left 1, up 1. Took this point here, 1, 1, left 1, up 1. Took 9, 3, left 1, up 1. I'm off by a little bit. But you get the idea, I hope. And if not, you just make the table of values. Nothing wrong with doing tables. Tables are great. So now that we see the graph, figure out the domain and the range of it. Again, domain is x values. You can see the x values, they can't go over here at all to the left of -1. Because if you put in a -2 or -3 or -4 or -5, you get a negative radicand. You can't do that. So the domain would have to be numbers that are bigger than or equal to -1. And the range is kind of similar. You'll notice it never gets down below this horizontal line right here. Doesn't get into this. Definitely doesn't get into negatives. Gets into positive fractions right here, but that never goes above 1. So it has to be greater than or equal to +1. And again, both of those are affected directly by these numbers inside and outside the radical. All right. So finish this off with a question. There's 2 graphs shown on here for these 2 functions that are shown. I don't know why I spelled that wrong. Spelling doesn't count on this particular assignment, I guess. So it says find the domain, just domain, no range on this one. Find the domain visually. So look at the pictures. What's the domain? This one you can see precisely. The domain is x values greater than or equal to 6. So this is pretty straightforward. It's all those x values to the right of 6, including 6. This is much harder to see. Now, if this 3 wasn't right here, you'd probably tell me the domain is -5. You can plug in -5. That 3 messes things up because -5 times 3 would change how big that can be. So here's what we need to think about. Like I said, this is the easy one. This one, it looks like 1 3/4, -1.5, -1.75. It's -1 point something. I don't know exactly what it is. So here's how we do this. We take whatever the radicand is, whatever's inside the radical, and we tell it, you have to be positive. You cannot be negative. I'll write it over here, you have to be greater than or equal to 0. That's what this means. If something is greater than or equal to 0, it's positive. Or 0. And that's why the equal sign's there. It could be 0, like this could be 0. As a matter of fact, if this is 0, that tells you where the vertex is for that thing. To make this 0, what would you plug in there to make this equal 0? 6. Well, that's where that 6 comes from. This is just like finding the zeros of a parabola. It's a very similar idea. What would you plug in there to make this equal 0? Well, if you haven't figured it out yet, let's just solve this. How do you solve this equation from Math 1? You subtract 5. 0 minus 5 is -5. Then you divide by 3. -5 divided by 3 is -5/3. Now, it's hard to see this on the graph. What is that? Well, this is also, another way to write this as a mixed number would be -1 2/3 -1, and there's 2/3. There it is. Bingo. So essentially we do this just by taking the radicand, whatever the heck it is, and saying you have to be greater than or equal to 0. And I solve that inequality, and that will tell me the point where the domain starts happening that we can't go past. Can't go over here. Can't plug in a number like -3 or -2, and it would make this negative too big inside the radical to be able to cancel out with 5 there. Hopefully that makes some sense. It is kind of like finding the roots or the solutions of a graph. Yes, it's not a coincidence of that relationship. And there it is visually. You can match it up and see where I'm talking about. All right, try these next two. They should be good ones to finish on.